Labor in the AI era, crisis or catalyst, abstract, then introduction, revolutions and ripples, the need for robust institutions, vision to viability, AI's real world challenges, differentiating between breakthrough and practicality, reliability, the infrastructure challenge, resource challenge, AI and India are their opportunities, the labor market evolution, augmenting India's services sector, and conclusion. So let us start from the beginning. Labor in the AI era, the rapid advancement of artificial intelligence presents both unprecedented opportunities and significant challenges for labor markets worldwide. In this context, as policymakers, it is important to pay attention to the evolving technological landscape and the potential impact it can have on the labor market. Historical parallels with earlier technological revolutions reveal the critical role of inclusive institutions in managing disruption and ensuring equitable outcomes. Barriers to large scale AI adoption persist in the present, which includes concerns over reliability, resource inefficiencies, and infrastructure deficits. These challenges, along with AI's experimental nature, create a window for policymakers to act. India's demographic advantage and diverse economic landscape position is uniquely to benefit from AI. However, achieving these benefits requires significant investments in education and workforce skilling. Supported by enabling, ensuring, and stewarding institutions, these mechanisms can help workers adapt to changing demands while providing essential safety nets. By fostering collaboration between policymakers, private sector, and academia, India can align AI driven innovation with societal goals, ensuring inclusivity and sustainability in this transition is the key to maximizing benefits while minimizing disruptions. With robust institutional frameworks and strategic planning, AI can serve not as a crisis but as a catalyst for equitable economic transformation, positioning India to thrive in an increasingly automated world. Concerns and fears about artificial intelligence disrupting labor markets have intensified as development in the field have continually demonstrated rapid progress over the last 4 years. The increasing complexity of the models being developed today represent a paradigm shift in the field of AI, showing the world that in a few years intelligent machines will be capable of performing tasks that are predominantly handled by humans today. The founder of AI research and development company OpenAI recently started in a blog post how they are expecting to have office ready AI workers by the end of 2025. Expectations point towards a trend where where AI begins outperforming humans in critical decision making processes in areas like healthcare, criminal justice, education, business, and financial services, among others. Adding to the uncertainties of the tomorrow is the fact that speed of research and development is outpacing the regulatory and ethical frameworks needed to manage its risks. Further, with executives optimistic about the capabilities of AI and the cost saving potential they expect it to possess, the impact of AI on labor market, particularly entry level jobs, is turning into a point of concern for policymakers. This economic displacement adds to the broader sense of unease about whether AI will exacerbate existing social and economic divides. With AI research and development currently concentrated in the hands of a few very large companies that control the resources to erect high entry barriers, AI adoption in place of humans present the risk of concentrating the benefits of automation. Kondrak and Stiglitz warn that labor and resource saving automation could produce winner-takes-all approach to the detriment of developing countries who are labor and resource rich. Technological developments that worsen inequality can erode any possible benefit that innovation brings, leaving the public sector responsible for addressing the cost of the transition. This has led to the calls for a more responsible approach to AI adoption, especially in a country like India where employment numbers make the magnitude of impact something worth paying to. Although until this point the use of AI/ML enabled tools and applications were already widespread and part of productivity suites for years, the end users face time with the integrated AI features were minimal and unconscious. Examples: the autocomplete function of the smart keyboard, Google and Apple smartphone visual assistants, personalized recommendations on e-commerce platforms and media streaming services, and curated feeds on social media websites and all. Most never paid attention to the host of ML Power featured while enjoying the convenience they delivered. This change in light of development witnessed in the last 4 years, the predictions about AI has now drastically shifted, the spurring debates about the need to align AI developments with broader societal goals. OpenAI has initiated an arms race in AI as between 22 and 24 many big tech firms have scrambled to capitalize on the demand for AI. Examples include but are not limited to Google Gemini, Microsoft Copilot, Meta Llama, X, Twitter Grok, Anthropic Claude AI, Midjourney, Perplexity AI, Stable Diffusion, among others. The number of AI patents globally increased 62.7% to just 62,000 between 2021 and 2022. Similarly, the annual global private investment in generative AI surged between $3 billion to $25 billion at the end of 2023. Between 21 and 23, global corporate investments in all type of AI totaled $761 billion. Additionally, an increasing share of companies have been referencing AI in their earning calls lately, with CEOs expecting AI adoption to lower labor requirements. If we look at these trends at the value generation expected from investment, it would appear that if AI revolution is here and labor is going to be a thing of the past, unease about what AI entails for workers and what it means for humanity as a whole has become part of daily discussions among academicians and policymakers as reflected in many publications and reports. Between 21 and 23, global corporate investments in all types of AI total $761 billion. Similarly, the number of AI patents globally increased 62% to just over 62,000 between 21 and 22. Annual global private investments in generative AI surged to $25 billion. Additionally, increasing share of companies have been referencing AI in their earning calls lately, with CEO expecting AI adoption to lower labor requirements. Since there are many unknowns associated with AI at this point, looking at the present through a lens of previous technological revolutions may provide some insight into the way forward. Advancing the understanding about challenges and opportunities that lie ahead is the purpose of this essay. In this sections, in this regard, section 2 brings to light the adverse effects that emerged during previous technological revolutions and how they pertain to present day concerns about AI. Section also elaborates on the importance of remaining cognizant as disruptions that are not carefully managed can lead to permanent societal damage for a country like India. Section 3 goes on to discuss how these risks can be minimized through a creation of social infrastructure, that is institutions. The priority is minimization since risk can never be fully mitigated. That is the price of innovation induced creative destruction. Innovation induced creative destruction. The various types of institutions detailed in this section can provide much needed support system to ease the pains of transition. However, building institutions is a time consuming process, requires concerted effort from the public sector, private sector, and members of academia. Section 4 would put forward the hypothesis that in India at present is afforded this time due to the challenging nature of scaling up technological adoption. Deployment at scale will require AI developers to address key challenges which require non-trivial amount of time. Section 5 then outlines possible opportunities that AI may open up for India. It seeks to visualize possible labor market evolution where future of work is augmented by AI. Whether or not we go down this path will depend entirely on how robust our institutions are. Revolutions and ripples. The present discourse on AI from international organizations and social science researchers postulate that large scale labor market disruptions due to AI may materialize in the near term. The International Monetary Fund states that AI poses risk of job displacement, notably for emerging markets and developing economies, which are not well placed to leverage the technology relative to advanced economies. The ILO estimates that nearly 75 million jobs globally are at complete risk due to complete risk of automation due to AI. Estimates for the UK show that 7% of the existing UK jobs face the high risk of automation in the near term, rising to around 18% in 10 years. Industry experts have told media outlets that AI models could dramatically disrupt the labor market, including replacing routine jobs in some sectors. A study by Bank for International Settlement finds that 45% of jobs in the upper quartile remain exposed to AI. Estimates from the private sector paint a similar picture. McKinsey demonstrates how by 2030 up to 30% of the current work hours can be automated by generative AI across Europe and United States. In the line with the IMF estimates is insight from Ernst and Young, while the impact of AI on emerging economies is lower relative to the advanced economies, one can still expect 57% of occupations in emerging countries to be affected by generative AI adoption. Anxieties about effects of AI remain high in India. Considering our country is a services-led economy, 68% of surveys employed expect their jobs to be partially or fully automated. 40% believe AI will make their skills redundant. So with the findings, these jobs pay 13 to 17% salary premium or baseline estimates. AI skill demand across India's banking sector is also witnessing adoption among well-capitalized and large banks as per recent RBI study. These estimates are substantial when viewed through the lens of history. One could argue that concerns due to the degree are valid. Previous technological revolutions have been painful and the damage brought on has been long lasting. Andrew Haldane illustrates that in pursuit of productivity and profit, substitution of labor for capital has resulted in widespread economic hardship, damaging social cohesion. Each revolution displaced large segments of the workforce. Many struggled to find new employment, especially in geographies and occupations where the scale of impact was unanticipated or underestimated. Consequently, income inequality rose, and those who adapted to new technological demands saw their wages increase, while others experienced declining pay and fewer opportunities. Recent experience show that such drastic loss of employment among coal mining workers across the United States brought about by the energy transition demonstrate just how susceptible to jobs the labor market can be. Societal impact of these revolutions can also extends to economic disparities. Workers may not immediately benefit from productivity and profitability gains with technological advancement. For instance, during the early stages of industrial revolution, wages frequently lagged behind increases in productivity. These transitions were protected as it could take decades for displaced workers to find alternative livelihoods. First industrial revolution exemplifies this dynamic with workers who were laid off facing sustained unemployment well into the 19th century, a period known as Engels' pause. The societies were balanced between capital and labor was not carefully managed by capable institutions were marked by enduring hardships for many who were affected. Protracted labor displacement is something that a labor surplus country like India cannot afford. Our primary challenge is the challenge of numbers. As highlighted in the economic survey, India would have to create an average of 78 lakh jobs annually in the non farm sector by 2030 to cater to the rising workforce. Further, India is a majorly services driven economy with significant share of IT workforce employed in low value added services. Such jobs are more susceptible to automation as firms are in a bid to cut cost may substitute labor for technology. We see that in case of tech firms in India and BPO sector in Philippines, India is also a consumption based economy. Thus, the fall in consumption that can result from displacement of its workforce is bound to have macroeconomic implications. If the worst case projections materialize, this could have potential to set the country's economic trajectory. Of course, in such situation, placing a higher weightage on the possibility of an adverse consequence is required as complacency can amplify any negative in fact. In the words of Alan Greenspan, uncertainty is not same as risk. Uncertainty involves unknown probabilities and outcomes with tremendous consequences. Any outcome with tremendous consequences need to be taken seriously. The need for robust institutions, minimizing the magnitude of such negative effects resulting from creative destruction, always necessitated a societal response where one social infrastructure is where where new social infrastructure is created to foster environments where innovation drives inclusive growth. The most notable work highlighting importance of institutional capacity is Darren Aclimoglu and James Robinson book Why Nations Fail. Inclusive institutions can promote broad participation in the gains from innovation and create conditions for sustained economic growth and prosperity. Eric Posner reinforces the importance of building adequate institutional capacity by posing out a grim scenario that is possible if most optimistic AI projections are to be believed. He states there is no social safety net generous enough to protect people from the mental health effects and society from the political turmoil that would follow from widespread disappointment and alienation due to substantial and permanent unemployment. High quality institutions act as mediators, ensuring that technological advancement yield broad based benefits. Enabling institutions are focused on equipping the workforce with the necessary skills to adapt and thrive in the shifting landscape. Further, they impart skills and augment the content of education, ensuring that learning keeps up with the demands of the job market. Further, as new auxiliary tasks and sectors emerge from the widespread adoption of technology, enabling institutions facilitate the smooth transition of workforce to these new jobs, reducing the damage to worker income and preventing loss employability. The latter is of paramount importance because if transitions are not carefully managed, workers can experience long lasting unemployment. As India's workforce in low skill and low value added services remain vulnerable to AI, robust enabling institutions are essential to help transition workers to medium and high skilled jobs where AI can augment their efforts rather than replace them. Ensuring institutions Ensuring institutions are intended to provide Ensuring institutions are intended to provide a soft landing for workers whose finances have been hit and well-being has been affected during the transitionary period. These institutions help secure a standard of living during the shift, keep inequities in check, and aid in keeping the social fabric cohesive. Ensuring institutions build safety nets such as National Insurance Act 1911 and Beveridge Report 1942 in the UK, protect workers' rights, provide finances such as in addition to the two outlined by Haldane, we propose the necessity of third institution, stewarding institutions. Second is ensuring institutions. First is enabling institutions. So, दो ये important याद रखने enabling institutions, ensuring institutions, and this economic survey proposes stewarding institutions. The product of science are neither good nor bad. What determines their net impact on society is how they are applied. This application depends on how society comes to define technology's utility, the ethics that govern its applications and rules, and the structure their place in society. It is important to clarify that stewarding in this case does not imply placing restrictions on innovation or dictating a narrow set of applications. It implies that policymakers demonstrate a certain degree of cognizance when it comes to emerging technology so that the need arises, they stand well placed to mitigate any adverse effects. Building each of these institutions is a time consuming process due to challenges involved in mobilizing the required intellectual and financial resources. Their need is not immediately clear in aligning with our social structures, regulators, cooperatives, and policy making institutions towards the distant goal is often an uphill battle. Another another reason Another reason we postulate that India has the time available to reinforce and build supporting institutions is due to the nature of technological revolutions. For technologies to be widely adopted, they have to overcome several obstacles that make them ubiquitous. Historically, technologies that have positioned themselves as general purpose technologies have done so through refinement and increasing cost effectiveness. This then created the demand for the technology reorienting macroeconomic processes around it by changing the way we invest, what we demand, education we impact, and quantity of labor we demand. Vision to viability: AI's real world challenges, differentiating between breakthrough and practicality. A breakthrough in the context of technology refers to a significant discovery that overcomes a major barrier, enabling new possibilities or dramatically advancing the state of art. It is also characterized by its ability to solve previously unsolvable problems, introduce novel capabilities, or revolutionize existing systems. Conversely, practicality refers to feasibility, effectiveness, and usefulness in addressing real world problems. So, a breakthrough in the context of technology refers to significant discovery that overcomes major barrier, and practicality refers to feasibility, effectiveness, and usefulness in addressing real-world problems. At its current stage of development, AI is more experimental as it's still finding its footing. This is not inherently negative, as it signifies innovation's curious and exploratory nature. However, from a practical standpoint, its experimental nature makes its real-world utility unclear despite the technology demonstrating impressive capabilities. For instance, the pursuit to make smaller AI models promises to propel the application of self-driving cars, but identifying why they are needed, their cost effectiveness, and social acceptability remains an ongoing challenge. Similarly, chatbots can convincingly simulate human conversation, but their practical effectiveness in customer service is not established since customers prefer having their complex questions dealt by with humans. Industry has placed its chips on increasing AI adoption, hoping that technology reaches a broad an audience as possible. Users will on their own eventually come up with more applications. Next is reliability. In the most day-to-day cases involving personal use, even an error rate of 10% would not have any significant impact since the user would most likely identify the error and correct it. The stakes are much higher when it comes to deploying AI in business and real-world applications, as the severity of the consequences will vary from application to one application to another. A customer service chatbot might have many chances to correct misunderstandings, whereas a path planning algorithm for an autonomous vehicle gets only one chance to get it right, ignoring the reliability problem and hasty implementation in severe unintended consequences. Several examples: a self-driving car fatally struck pedestrian on a four-lane road because it failed to recognize the individual as a pedestrian, as the person was not near a crosswalk, which was typical circumstance represented in its training data. The company attempted several times to make AI screener general neutral but failed. Predictive policing using AI also tends to have bias against minorities. Application of AI in recruitment turned out to prefer male candidates over female applicants due to larger number of males in its training sample. Time-tested liability frameworks applicable to commercial products may not apply straightforward to AI products, as solving the reliability problem is also necessary to mitigate risk from AI applications. Arvind Narayanan and Sayas Kapoor at Princeton note that LLMs are not reliable enough to be successful products yet. Infrastructure challenge. The third criterion for diffusion of new technology is growth in supporting infrastructure, as illustrated by Carlota Perez in her book Investigating the History of Technological Revolutions. Canals, waterways, and turnpike roads provided the connectivity required for industrial revolution, facilitating the movement of inputs and finished goods. The age of automobile gained momentum due to construction of roads and highways. The expansion of electricity grid provided households access to power. Proliferation of computers uh, created for telecommunications gave impetus to the adoption of internet. Once the technology has proven its practicality, infrastructure creation naturally followed. However, since building infrastructure is highly time consuming process, the full potential of the technology could not be harnessed till the support infrastructure was widely available. Development of AI, the rate of adoption is similarly going to depend on the availability of quality infrastructure and the pace of its creation. Infrastructure in case of AI is not straightforward in the previous technological revolutions since its requirement transcend the physical realm. Apart from already known aspects such as land, reliable chip supply, and data centers, chief among AI infrastructure is data, which is the lifeblood of AI development. Training AI models cannot be done on raw data as previously discussed. Data is highly prone to bias the model. Additionally, data in its raw form can include instances of toxicity, vulgar content. More often than not, prior to data making its way into the training set, it is extensively cleaned by humans who filter the dataset to any or all of the issues mentioned above. For AI to be widely adopted across industry, a holistic infrastructure that combines technological resources, human expertise, and organizational readiness is needed. Third is resources challenge. Most notable critical obstacle to large-scale proliferation of AI in the medium term is resource efficiency. For AI to scale, technological advancement and performance gains must be coupled with significant reduction in cost and more efficient utilization of scarce resources. Training AI models is becoming increasingly expensive as availability of data is saturating and high quality acquisition costs are rising. Training the first transformer model developed by Google, which laid the foundation for ChatGPT, cost around $930 US dollars. In contrast, training OpenAI GPT-4 cost the company $78.4 million, which the cost incurred by Google for training Gemini Ultra stood at $191 million. As costs are only expected to go up, developers have been exploring the idea of using synthetic data, but this rife This is rife with its own set of challenges. Artificially generated data comes with data distribution bias, are characterized by completeness which influences models' resilience. Secondly, developing more sophisticated models comes with significant cost as well. AI firms running, for instance, in the case of OpenAI O3 model mentioned earlier, the breakthrough in processing capability came at a very high cost in running the ARC-AGI benchmark, which is considered one of the challenging tasks for an AI to undertake. OpenAI incurred $200,000 for its low efficiency model. In this regard, AI's energy requirements are no mystery. Globally, all data centers consume more electricity than countries such as Italy, Taiwan, Australia, Spain, Malaysia, among others. Without groundbreaking innovations and strategies to make AI scaling economically viable, both financially and in terms of resource consumption, efforts to democratize AI will jeopardize critical global priorities such as energy security, technological revolutions that achieved mass adoption did so because over the course of time they got delicate mix of factors outlined in the previous sections, right? Practicality, reliability, infrastructure and efficiency need to work in tandem before true large scale adoption happens. AI and India, are there opportunities as AI contemplates the integration of AI into its economy? The lessons of past technological revolutions underscore the critical importance of proactive institutional response. The time afforded now must be well utilized to minimize the adverse effects to the best of our capabilities. Looking ahead, nation's predominantly services driven economy coupled with its young and dynamic population offers a fertile ground. Further, the exposure of medium to high skill jobs to AI driven automation may not be as high as certain estimates due to inherent limitations of AI. In the simplest terms, AI tools on the market today, particularly generative AI, are statistical models utilizing significant computing power that are function of large amount of text, images, and other parts of data fed into them. When you ask any modern chatbot driven by underlying large language model is a simple question, where does sun rise and set? The model does not interpret the language in the question as human does. This is because AI has no understanding of concept of letters and syllables. Machine processes input text using a series of mathematical computations involving matrices. First, the text is broken into smaller units called tokens, called tokenization, where each token is mapped to a unique number. For example, the phrase AI revolution might be tokenized as 3422591, where these numbers correspond to indices of the words in the model's vocabulary. Once tokenized, the models use mechanisms to compute the frequency of token pairs triplets. This allows the model to assign importance to the different words based on their context. These weight representations are passed through layers of neural network where patterns and relationships are defined. The new tokens are then fed back into the model, making it appear that the bot is equipped to have a flowing conversation with the user. Thus, to respond to a user's query, the data analysis performed by the model is essentially a game of guess the next word. In other words, it is a highly complex version of autocorrect function we already see on our computers and smartphones. Generative AI are trained to simply predict the next word in the sequence of words by calculating probabilities on the user input text. To generate a single line response to the user question, the model may need to perform anywhere between 10 to 20 trillion arithmetic operations to generate a 11-word response. Considering AI power marketing tool that determines campaign success based solely on click-through rates and conversions, while efficient, it might ignore brand perception, customer loyalty, long-term impact of the campaign on the business. In education, that evaluates essays based on grammar, structure, word count can be quick and efficient, but the AI may miss value brought out by creativity, originality, and critical thinking expressed in the content. AI in healthcare can recommend treatments that prioritize statistical outcomes since it cannot factor parameters such as quality of life, patient preferences, ethical considerations. Advancement in computer science just may as well address these concerns in the future. In the meantime, just as machines are designed for specific tasks rather than universal applications, AI functions as a tool tailored to particular purposes. Next is labor market evolution. Labor and technology, when integrated in the right way, have complemented one another rather being substitutes. Further, technical change did not always lead to declining employment in the affected industry. Rather, it has resulted in strong employment-based growth. For example, Besson investigated the impact of automated manufacturing had on textile, steel, and automotive industries. Findings demonstrated productivity gains due to automation led to robust job growth. Studies assessing the introduction of robots in factories corroborate the same. Similarly, in Albanese, among others, introduced much needed balance to the literature of effects of AI/ML led automation on white collar jobs suggests that there exists a positive association between AI-enabled automation as sector occupation employment share of the high-skilled workers increases in the range of 3.1 to 6.6%. Research has already demonstrated how the introduction of generative AI assistants augmenting customer support personnel increased productivity by 14%, including 34% improvement for new and labor skilled workers. In more complex fields such as scientific research, human AI teams are able to generate high quality outputs by capitalizing on the best of human and machine intelligence. AI assisted research design benefit in five core aspects: questions and literature, generating testable hypotheses and methodologies for testing instructions and comprehension checks, generating experimental code and related documentation, and auditing for errors. Supplementing human decision making with AI assistants would be ideal for most desirable outcome for maximizing the micro and macro benefits of the technology. Further factors such as accountability and understanding of the subjective and practical realities, consistently adapting reasoning, cognizance of consequences, and critical thinking are important factors which human capital brings to the enterprise. AI must be seen for and utilized as what it is supposed to be, a tool, as the arc of technological history does not bend towards replacement of humans by machines. Augmenting India's service sector. India is a services driven economy, and the opportunities and for enhancing the productivity of the workforce are ample. Further, the young population of the country makes the rich talent pool available for capitalizing on emerging technologies. This is significant because Al- Albanese and among others analyzing the effects of AI/ML in Europe revealed that youth and high skilled workers were the demographic most capable of understanding and adapting to technological changes. Education and skilling are going to play a critical role in driving the success of human-centric AI adoption. The Industrial Revolution demanded a labor force skilled in handling factory machines. Age of steam and railways shifted from the employment landscape towards industrial and urban jobs, primarily in construction operations maintenance. Age of steel, electricity, and heavy engineering demanded workforce capable of handling large-scale machinery, electrical equipment. Within IT information, jobs shifted towards knowledge-based and service-oriented jobs. As the developments in field of AI create tools of automating basic knowledge creation and processing, skills such as critical thinking, high degrees of creativity, and the capacity for more specialized knowledge may well be the new normal. Thus, India's employment challenge is not just about numbers but also about raising the overall quality of the workforce. Quality in this case does not mean imparting knowledge through step by step guide to leveraging AI or providing very specific training to AI oriented jobs. Technology specific skills run the risk of becoming obsolete very soon. In addition to above, improvements in the quality of workforce must focus on foundational skills as well as such as soft skills and core competencies. Furthermore, Besson finds that technological change is only labor displacing and bringing about mass unemployment if the demand for the product and service offered by the industry is saturated. If the market has large unmet needs, then the labor augmented by machines increases productivity and employment. What happens to work in the presence of automation? Often, automation does away with subtasks within a job, in leading to modification of job profile, then the job being suppressed entirely. Role of bank teller over time exemplified how automation leads to new subtasks has taken up alongside over routine. ATM did not lead to loss of bank employment, rather bank employment has grown and role of bank teller has shifted from clerical work to sales and counseling over time. Ultimately, capacity of sector to create jobs response to automation depends on whether the new grouping of subtasks into specific job profiles is deemed profitable. This, in turn, a function for demand for particular services delivered, then the supply of skills to fill these jobs. Understanding the nature of demand for a particular sector therefore reveals clues as to how a sector will respond to technological change. While some sector of work displacement is inevitable for those with aligning with shifting skill requirements, Uh, these researchers found that technological change is only labor displacing and bringing more mass employment if the demand for the product service offered by the industry is saturated. While some level of worker displacement is inevitable for those unable to align with shifting skill requirements, the scale of displacement is shaped by interplay between displacement effects and productivity gains. For instance, in a highly demand elastic market, the restatement effect has historically acted as a counterbalance against the displacement effect caused by automation. Reinstatement effect. Technological advancement in markets with unmet demand often give rise to auxiliary tasks where labor maintains a competitive edge. As Akimoglu and Restrepo observed, such tasks not only enhance productivity but also restate labor into a broader spectrum of goals. Elasticities for India's services sector and estimation. So, demand elasticities can help gauge a sector's ability to raise employment because of productivity enhancements from automation. तो demand elasticity का function create किया uh, given by del ln upon del ln w by p. So to understand the potential for employment increases in India's service sector, Besant theoretical model is replicated with the data from RBI KLM EMS database. The data studies is for the period of 94 to 23, and what do we get? डिमांड इलास्टिसिटी फाइनेंशियल सेक्टर में सबसे ज़्यादा है, पोस्ट एंड टेलीकॉम में सबसे कम है. Financial sector shows the highest velocity, followed by health and social work. Implications: a sectoral comparison estimates reveals that demand elasticity has higher sectors such as financial services, trade services, health, etc. For instance, as research by Schwalbe and Wahal shows that AI can aid productivity through interventions in diagnosis, patient mortality risk assessment, disease outbreak prediction, and health policy and planning. Social work में AI can maximize the effectiveness. High elasticity in retail and wholesale trade is indicative of a larger consumption base in the country. Business sector is export oriented with activities such as IT and IT enabled services, R&D services in the areas such as accounting and legal professions. Education sector shows an inelastic demand for services. Theoretically, this may imply that productivity enhancements through AI based learning models can lead to decline in teacher employment. Post and telecom also show low elasticity. While initial displacement is to be expected for workers who fail to catch up to the market demands, the magnitude of displacement also depends on how displacement and productivity effects weigh against each other. Looking at history of the labor market through this lens, we can now decode why, despite major technologies that automated economic value addition, employment to population ratio rose over the 20th century. Along these lines, the future of work is augmented intelligence, one that expands the workforce to accommodate both humans and machines with the aim of improving humanity. With new opportunities will emerge from the spillover effects of AI will only be clear once AI goes from experimental to practical, but reinforcing the point made earlier, it is to policymakers, academia, and private sector to work together to raise all the overall quality of human capital. The tripartite compact is going to be instrumental in ensuring that gains from productivity are distributed widely, creating a social surplus rather than concentrating in the hands of increasingly oligopolistic sector. In the 7 decades since development of artificial intelligence began, progress has been made in the last decade lays down an important milestone for the domain. While impressive in its own right, AI still remains in its developmental stage and has a long way to go before it achieves the scope of adoption that have made technologies such as personal computer and internet ubiquitous. Scale of challenges left unaddressed are significant, and so is the time required by the developers to come up with cost-effective and resource-efficient solutions. As policymakers, it would benefit us to ask ourselves the question, what are the problems in the world that demand AI as the answer? In the words, is AI a solution in search of every problem? The question is not easily answered as innovation does not always respond to a problem, rather emerges as a product of human ingenuity. Thus, in some sense, AI represents the human drive for improvement, for creating something previously thought impossible. However, when innovation has the possibility of coming at great societal cost, the value of innovation must then be judged in the context of its potential loss generation. Despite the limitations of AI and prerequisites necessary for its widespread application, it is worth taking notice of the fact that labor markets are shifting at present in anticipation of a distant future. Learning from the lessons of the past, capacity building and institution building is the need of the hour to capitalize on the opportunity that lies ahead. Structural changes to how we educate our children will be required in addition to safety nets. Corporate sector has to display a high degree of social responsibility. Although the impact of AI on labor will be felt across the world, problem is magnified for India. It will leave everyone worse off and the country's growth potential will suffer as a result. The state in turn has to resort to taxation of profits generated by the replacement of labor with technology to mobilize those resources. If companies do not optimize the introduction of AI over the long horizon and do not handle it with sensitivity, demand for policy intervention will be irresistible. So, utilizing this window of time available during the nascent stages of AI to build robust institutions can ensure that we as a nation are well placed to minimize the cost as much as possible. This can then help tilt the scale towards the benefits, bringing a balance to cost benefit aspect in a labor driven services dependent economy like India. Navigating this transformation necessitates coordinated participation from all agents of the economy. A tripartite compact between the government, private sector, and academia can ensure that gains from AI driven productivity are widely distributed, taking us in the direction to ideal inclusive growth strategy. Profitability of success in this endeavor is directly proportional to the appreciation of enormity of the challenge and the gravity of consequences of failure. Appreciation of enormity of the challenge and gravity of the consequences of the failure. So that's all. See you in the next one.